Okay, today's lesson has several topics on it, so make sure you're completely with me and make sure you are understanding what it is that you are watching so that way you can do the assignment next time you have me in class. So we're going to be talking about exponential notation and the product and the quotient of powers. So if you look below, we have some examples including exponential notation. We're on page 2 of our notes, by the way. Also, identify the base and exponent in each expression. So number 1 says 5 times 5 times 5 times 5 times 5 times 5, which means you're multiplying 5 by itself 6 times. So that means that it's just 5 raised to the 6th power, okay? The base is the number that is being multiplied by itself repeatedly. So in this example, our base is 5. And the exponent tells us how many times we're multiplying a number by itself. So this right here is going to be 6. All right. So number 2 would be 9/7 raised to the 4th power, right? So what I would do is I would say 9/7 all raised to the 4th power. Now here's the thing though. What I'm going to say next is crucial. When it's written like this with this 9 to the 4th power, it seems like only 9 is being raised to the 4th power, but the whole entire number is being raised to the 4th power. So we must include parentheses. We have to say it's 9/7 the whole thing raised to the 4th power. Okay? So that means that in this problem, our base is going to be 9/7 and our exponent is going to be 4. Okay, so our base here is 9/7, and then our exponent is 4. Now in number 3, we're going to go the opposite way. We're given our number in exponential notation, and we're going to expand it out. So what this means is I'm just going to multiply -4/11 times -4/11 times -4/11, because the base is -4/11, and you're multiplying it by itself 3 times. So the exponent is 3. All right. In number 4, you have -2 to the 6th power, which means that you're going to multiply -2 by itself 6 times. All right. So in this example, -2 is the base and 6 is the exponent. Now, at the top of your paper, there's a box on the right side, and it says, did you notice that the parentheses are used in questions 2, 3, and 4? Why do you think there are parentheses? Well, what's different about number 1? In number 1, it's just one single number. It's just 5 being raised to the 6th power. But in number 2, you have a whole fraction, so we need to indicate that the entire fraction is being raised to the 4th power. So I need parentheses to show that all of 9/7 is being raised to the 4th power. In number 3, same thing, it's a fraction, so we got to show the whole thing is being raised to the 4th power. And in number 4, without parentheses, so watch this because this is going to be really important. You're going to be responsible for this information. Without parentheses, if I were to write it out like this, what this means is the 2 is being raised to the 6th power, so it means 2 times 2 times 2 times 2 times 2 times 2. With a negative in front right here, which is different than what this says. So this is incorrect. So in order to have to indicate that the 2 is negative and the whole entire -2 is being raised to the 6th power, you need to have parentheses. So the reason why we need to have parentheses is to show the entire number that is the base. So again, if you look back right here in number 4, without the parentheses right here, the base would have been +2, not -2. Okay, so go ahead and try question number 5, and then press pause before you move on. Try number 5 individually and then come back to me to see how you did. All right, in number 5, you should get 3.8 multiplied by itself 4 times. By the way, you can't go wrong with too many parentheses. If you have extra parentheses, it's fine. you can go wrong with too little. Okay, so if you had parentheses here, great. If you didn't, that's totally fine because it's just a single number, which is 3.8. Okay, so our base right here is 3.8, and then our exponent will be to the 4th power. Okay, now we're taking a look at page 3 of our notes. The directions say to try these exercises on your own, then compare with your partner. Obviously, you're doing this at home, so you might not necessarily have a partner with you. So I will be your partner. So I still want you to try the 10 exercises on your own, and then when you're done, see how you do compared to me. So press pause, try questions 1 through 10, and then come back to me to see how you did. All right, and number 1, you should get 4 to the 7th power. With parentheses, without parentheses, totally fine. Number 2, 3.6 raised to the 47th power means that this is being multiplied by itself 47 times, okay? In exercise number 3, you have negative 11.63 raised to the 34th power, and you absolutely do need to have parentheses because that number is negative, all right? And number 4, 12 is being raised to the 15th power, so 12 is being multiplied by itself 15 times, okay? And number 5, negative 5 is being multiplied by itself 10 times, so it's going to be negative 5 to the 10th power. Parentheses are absolutely necessary for that question, all right? And number 6, 7 halves is being raised to the 21st power. Again, you must have parentheses to indicate the whole thing is being raised to the 21st power. And number 7, negative 13 is being raised to the 6th power. Parentheses are necessary. In number 8, you should get negative 1, 14th, all raised to the 10th power. In number 9, x is being multiplied by itself 158 times, or 185 times, excuse me. So the answer to this right here should be x to the 185th power. And then lastly, number 10, you should get that x is being multiplied by itself n times. Now, in number 11, will these products be positive or negative? How do you know? Well, in number 11, the first example, we have negative 1 multiplied by itself 12 times. So what I'm going to do is I'm going to make a simpler problem, and I'm going to see what do I get when I multiply negative 1 by itself twice. I get a positive 1, okay? Now what happens if I add an extra negative 1 onto this? So it becomes positive 1 times negative 1, which gives you negative 1. So if you guys notice right here, what I'm going to do is I'm going to pair up all of my information right here. So if I have a negative 1 multiplied by itself, I'm going to write it out 12 times. I know that these two will multiply together to give me a positive because two negatives give you a positive, right? And then these two will also multiply together to give you a positive. So will these, so will these, so will these, and so will these. So all of these end up being positives, which means that I get a positive answer. But how do I know that I end up getting a positive answer? It all has to do with the number of factors that you have here. Here we have 12 factors. In the next example, we have an extra negative 1. And this is not being multiplied by any more negative 1s, which means I've got all positive numbers here multiplied by this negative, so my answer right here is negative. I want you to think about this for a couple minutes, press pause again, see if you can figure out how you can figure out whether the product is going to be positive or negative. All right, welcome back. You should have gotten that this answer is positive because the exponent is an even exponent. And when you have an even exponent, there's an even number of factors, which means that the even numbers will multiply together to give you a positive, right? Because again, two negatives will give you positive two negatives. As soon as you have an odd number, this odd man out right here doesn't have a partner to turn into a positive with, so that means that the answer is going to be a negative number. So the reason why this one is negative is because the exponent is odd. Okay. All right, so take a look at page 4. Is it necessary to do all of the calculations to determine the sign of the product? Why or why not? So all I want to know is this product going to be a positive number or a negative number? So I could multiply negative 8 by itself 95 times, but that's going to get ridiculously annoying, especially since all I want to know is this number positive or is this number negative? So again, just like in the previous exercise, it all comes down to what this exponent right here is. This exponent is an odd exponent, right? Which means that 94 of the negative 5s that are being multiplied together will have a partner, but there's going to be one negative 5 left over, which means that I will have a negative answer, okay? So the answer to this question is no, it's not necessary. All you have to do is look at the exponent. And in this specific example, we can say that the product is negative because the exponent is negative. Excuse me, not negative, because the exponent is odd. Okay, so let's look at this next one right here. It's the same answer. It's not necessary. All you have to do is look at the exponent, but in this example, the exponent is even. So we're going to say that the product is positive because the exponent is even. Okay, since there's 122 of these negative numbers being multiplied together, each one will have a partner, and the two partners will match up to get a positive number. All right, so go ahead and see if you can fill in the blanks in exercise 13. When you're done, come back to me and see if you get the same answer as I do. All right, if n is a positive even number, then negative 55 to the nth power is going to be what kind of a number? Well, if it's even, each negative 55 will have a partner to balance out to become positive, so the answer is positive. Okay? If n is an odd number, a positive odd number, then negative 55 to the nth power is negative. All right, hopefully all of that makes sense to you guys. All right, so now exercise number 14. Josie says that negative 15 times 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 negative 15 is negative 15 to the 6th power. How do you know? Or sorry, is she correct and how do you know? Well, if you have 6 of these right here, these will become positive, positive, positive. So that means that the final answer is going to be a positive answer. Okay. But if you look at this right here, in this example, the base is just 15. So what this means, we talked about this before, but what this means, again, is 15 multiplied by itself 6 times with a negative tagging along in the front. So this answer is going to be a negative number. So she is incorrect, because there's no possible way that a positive number could equal a negative number, okay? And remember, the base is just 15 because without parentheses, the number that's being raised to the 6th power is just 15, okay? So the answer to this question is no, she is not correct. Because negative 15 to the 6th power is negative, while her product should be positive. Okay? And then we'll say, it should say -15 in parentheses raised to the 6th power. All right, hopefully that makes sense to you. All right, exercise 15, -3/4 raised to the 3rd power. All that means is I'm going to multiply -3/4 by -3/4 by -3/4. And hopefully you remember how to multiply fractions. You just have to multiply your numerators. So it's just going to be -3 times -3 times -3. So 3 times 3 is 9, times 3 is 27. But with an odd number of negatives, you should get -27, okay? Now, the negatives are only for one of the numbers, not for both of them. So I chose them to be for the 3s. It doesn't matter. You can make it for the 4s, but it cannot be for both of them, okay? And then 4 times 4 is 16, right? And then 16 times another 4, let's figure that out. 6 times 4 is 24, carry the 2. 1 times 4 is 4, plus 2 is 6. So I get 64, which means that this answer right here is -27 over 64. Okay, now we're taking a look at page 5. Now that we understand what exponential notation is, we can go through and actually use it to help us figure out how to do operations with exponents. So in question number 1, it asks us to expand 10 to the 6th power. So basically, all I need to do is write out what this means. All 10 to the 6th power means is 10 multiplied by itself 6 times. Okay, you don't need parentheses here because you don't have a negative number, but it's okay if you have it, okay? And then in question number 2, it says to expand 10 to the 3rd power. So go ahead and do that. Hopefully you get 10 times 10 times 10. Now, it says to expand 10 to the 6th power multiplied by 10 to the 3rd power, right? So let's go ahead and do this. 10 to the 6th power means 10 multiplied by itself 6 times. And then 10 to the 3rd power means 10 multiplied by itself 3 times. So what you end up getting is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10s being multiplied together. So remember what this means right here is just 10 to the 9th power. And all we did is we took 10 to the 6th power and multiplied it by 10 to the 3rd power. So hopefully you can figure out what the shortcut is looking at your exponents. See if you can figure out what is the shortcut. What can I do with my exponents? Instead of writing out 10 multiplied by itself a bunch of times, what could I do instead? So let's see if it works for question numbers 4 through 6. So in question number 4, you have a to the 4th power, which means a times a times a times a, okay? And then in question number 5, you have a to the 5th power, which means a times a times a times a times a, right? So then if I'm going to if I'm going to expand it out and multiply the two problems together, I end up getting a times a times a times a, and then I've got another set of 5 a's. Altogether, you have 9 a's, so this ends up being a to the 9th power. It's just a coincidence, by the way, in question number 3 and number 6 that they're both to the 9th power. But what's the shortcut? What can you do with your exponents to get a to the 9th power? Hopefully by now you figured out that all you have to do when you're multiplying is to add the exponents, okay? So let's fill in the blanks right here. When you find the product of two algebraic expressions with the same base, you can add their exponents and use this exponent with the same base. Now, if you guys notice, this right here, 10 to the 6th power times 10 to the 3rd power, didn't turn into 100 to the 9th power. It was still 10 to the 9th power because you have a bunch of 10s. The 10s stay as 10s. Here, the a's stay as a's, so your base always stays the same. So in this example right here, the general form If you have a to the mth power times a to the nth power, all you have to do is say that it's a to the m plus n power because you are adding those exponents together. Okay, I'm going to write this a little bit clearer so you can see it a little bit better. A to the m, a to the m plus nth power. Okay? All right, so now we're going to see what happens when we do these examples. So if I have negative 4 to the second power times negative 4 to the third power, all I have to do is keep my base the same, so it's still going to be negative 4. I must have parentheses, and it's all being raised to the fifth power, because 2 plus 3 is 5, okay? Now in number 8, this is a little bit tricky because it has an invisible exponent on this 3, but the 3 is there one time, which means the invisible exponent is 3 to the first power. So my final answer for question number 8 is 3 to the 7th power. Okay? Try number 9, press pause, see what you get, and then compare with me. Hopefully you got a to the 32nd power because 23 plus 9 is 32. All right? So now let's take a look at what happens when you divide. So in question number 10, you have 5 to the 6th power. So that means 5 times 5 times 5 times 5 times 5 times 5. All right? And in 11, you have 5 to the 2nd power. So it's 5 times 5. And it says to expand 5 to the 6th divided by 5 to the 2nd power. So what I'm going to do is I'm going to write it out a little bit different. I'm going to say 5 to the 6th right here, and then I'm going to say it's divided by 5 to the 2nd power, just like this right here. Okay? So then my answer right here is going to end up being, just like we did before, we have 6 5s being multiplied together on top, and we have 2 5s being multiplied together on the bottom. And all I have to do is see what happens to the top and the bottom. Well, if they're the same thing on the top and the bottom, they cancel out to give you 1 because it's 5 divided by 5, which is 1. But anything times 1 is itself. So I end up getting 5 to the 4th power. Hopefully you were able to figure out what the trick is for division, okay? But let's try one more and then we'll see if you can figure out what it is that you notice. So expand y to the 7th power. So that means I'm going to have y multiplied by itself 7 times. 1, 2, 3, 4, 5, 6, 7. And then I'm going to have y to the 4th being multiplied by itself 4 times. So when it asks me to divide the 2 right here, I'm going to write it out as 7y's on top and 4y's on the bottom. Now let's see what's going to cancel out to give us the number 1. So this goes with this, this goes with this, this goes with this, and this goes with this. So I have y to the 3rd power left over. So hopefully you figured out the trick. In number 2, you have 5 to the 6th divided by 5 to the 2nd. You ended up subtracting the exponents to get 4. And same thing right here, you have y to the 7th divided by y to the 4th. So you subtract the exponents to get y to the 3rd power. So let's fill this in right here. When you find the quotient of two algebraic expressions with the same base, you can divide, not divide, you can subtract their exponents, but you must use the same base and use the exponent with the same base. So a to the nth power divided by a to the nth power means a to the n minus n power. Okay, so in number 16, simplify your expression. 2 to the 9th power divided by 2 to the 6th power. Well, all I have to do is subtract my exponents, so I get 2 to the 3rd power. Okay, and then in number 17, remember there's an invisible 1 right here. Since this is division, I'm going to subtract my exponents, so I get negative 7 to the 4th power. Because it's a negative number, you must include parentheses. Number 18 is a little tricky. If you look right here, if you see the 35 and the 5 right here, these are called coefficients. So they're not the exponent and they're not the base. So you just deal with them like you would deal with normal numbers, okay? So 35 and 5 are coefficients. So all you have to do is divide 35 by 5 and you end up getting 7. And then all you have to do now is subtract the exponents for the bases that are the same. So you have x's and y's on top and x's and y's on the bottom. You can only subtract the exponents for the x's together and then subtract the exponents for the y's together. So you should get x to the second power because 4 minus 2 is 2. And then you should get y to the fourth power because 7 minus 3 is 4. Hopefully that makes sense to you. Make sure you indicate any questions you might have, and then I will help you out with it next time I see you in class. All right, have a good day.